Hello everyone, welcome back to the channel. Today we are going to solve this question action figures on the code forces, which is from the recent educational code forces round, which was rated for division 2. And the problem states that there is a shop that sells action figures near Monocarp's house. A new set of action figures will be released shortly. The set contains n figures. The ith figure costs I coins and is available for purchase from day I to day n. So for each of the n days, Monocarp knows whether he can visit the shop or not. So every time Monocarp visits the shop, he can buy any number of action figures which are sold in the shop. Of course, he cannot buy an action figure that is not available yet for the purchase. So if Monocarp buys at least two figures during the same day, he gets discount equal to the cost of the most expensive figure he buys. In the other words, he gets most expensive of the figures he buys for free. So Monocarp wants to buy exactly one first figure, one second figure, and so on. One nth figure means he wants to make a set of figures, each figure having count of one. So he cannot buy the same figure twice, and we have to calculate what is the minimum amount of money he has to spend. So the monocarp, if he can go or not to the shop, is characterized by the string, which is binary string. If it is 0 on that particular index, he cannot go to the shop on that day, and if it is 1, he can. So let us take a look at some example test cases. So here they are. So what seems logical is that, see, Monocarp cannot buy this first item at discounted price. Okay, we can get that because every item other item will be having the price greater than 1, and he has to buy the figures in the set of 2 to get discount. So he cannot make some profit or cannot avoid spending money on this first product. So that is one of the observation. Another observation, and the most important one, is that suppose this seventh seventh toy, okay, sorry, sixth toy, this sixth toy, okay, before that, another observation is like, whenever the str of index means string of index is 0, means at the corresponding index it is 0, monocarp cannot take that product at discounted price, or he cannot take it for free, because on that day he cannot buy that product or whatever figure. And if he cannot buy on that day, he will buy it on some another day, when he goes to the shop. But when he goes to the shop, the toy which has higher price is already available, so he will take discount on that higher priced figure than to take on the figure which had the index of which had the 0 at that same index. So therefore, for every every index such that str of index is 0, he cannot take out discount from it. And yes, so this drives us to our final observation, and the most important one, that I should, to optimize my price which I will pay or the monocarp will pay, I should choose this one and the 0 most most nearest to it. So starting from the right, traveling towards the left, whenever I encounter 1, I'll store it in some vector, or suppose priority queue. Why priority queue? I'll tell that. So I will store this one. So not store this one, I'll store its index 6, and whenever I encounter 0, I know that I can get this figure for the discount. So I can get this figure for the discount. I cannot get this figure from the discount. So next I will push this index 4 to our priority queue. 4 to our priority queue. Keep traveling left, then I'll push 3 because count of 0 is 0. And whenever I encounter 0, I can get this product for free. So I can get this product for free as well, using this product means second index product as my second product. So second product in the sense, in the pair which I will buy them. So and for oh, and I'll travel to the left. So I'll travel here. I have already pushed it. So travel here and I'll push it. So these 3 and 1 cannot get any discount any discount because uh, they cannot make the pair with 0, but they can make pair with themselves, right? So on the third day monocarp will buy third and the first product. So he will narrow his final cost to pay to this 1 plus, see, this index has 0, so definitely he will buy it. 1 plus 2 plus 3. 3 got discount, right? With this one, it got discount. 4 also got discounted with this 0. 4 also got discounted with this 0. And finally, 5 should be added. Plus, and this 7 got discounted with this 0. So, yeah. So, the answer for this test case should be 8. Is it true? Yes, indeed, it is true. So, similarly, we'll perform the same action on this string. So, for this one, we can get discount from this 0. So, answer will be 6 plus this 5 plus 4 plus 6 plus 5 plus 4 plus, now I will push it to the priority queue. 1, I will push it this also to the priority queue, the index, this 2 and this 2. And finally what I will make is that I'll make pair of 3 and 1 and get 3 for the discount, so it will be 1 plus, and I cannot make pair for 2, so I have to buy it at any cost. So the answer would be 6 plus 5 11 15 16 and 2 18. Is it? Yes, it is. And for this test case, I will keep pushing 5 4 3 2 1 to the vector. Suppose helper vector is there, and we cannot we are not finding any 0 here, so we will make pair of 5 and 1, make pair of 4 and 2, and actually by 3. So total price I should pay is that 3 plus 2 plus 1 is equal to 6. So this is the answer for this test case. So it is indeed true. And let us take a look at this bonus test case. So you should be asking, right? So why should we group this 0 with the last product only? Why cannot I group this with this? So let us check what happens. So if I group this with this with this with this, and take this alone, so my costs will be this 1 plus 3 plus 5 plus 7, which would be 16, sum of first four odd numbers it is. And finally, if I do with our optimal method, it would be like this: we will get for a discount, this we will get for a discount for this 0, seventh action figure will get discount from this 0, sixth will get discount from this 0, and this fourth will get discount from first 0. So our final answer would be 1 plus 2 plus 3 plus 5, because 7 6 and 4 are getting discount, so which will be 8 and 3 11, so 16 is greater than 11. So by using our approach you can optimize the cost that monocarp should pay, monocarp should pay to get all the action figures. So let us head to the code. How, see, the implementation is pretty easy. You'll just declare a priority queue pq, and our maximum answer 1 plus 2 plus 3 plus 4 plus so on up to n will be n into n plus 1 by 2. And whenever I can reduce that index from the our answer, I will reduce it. So I'm maintaining one, this thing, priority queue, and if str of I is equal to 0 and pq is not empty, if pq is not empty, then we know that we have stored some indexes which are yet to be neutralized, neutralized in the sense to get discount on. So we will do answer minus is equal to pq dot top, which is the, which will be the highest element that we will get discount on, and then pq dot pop, we will pop that element from our priority queue. And else if str of I is 1, we will simply push that index or whatever cost it is to the priority queue. And finally, if priority queue is empty, we will directly output our answer. And if it is not, we will do this thing, this thing we have done in this test case, right? 5 1 1 1 1, we will make those elements which are in priority queue to go to the vector, some helper vector, and then what we will do is that group them by the end by end. So 5 to 1, 4 4 to 2, and if its size is odd, we will just add it one another time. So this is what implementation does. If help dot size is not divisible by 10 or divisible by 2, then answer plus is equal to help of mid, and that is it. So finally outputting the answer, so this nicely passes the given time limit and memory limit as well. So yes, this was a nice application of the priority queue. Hope you enjoyed the video and the solution as well. Thank you for watching the video. Like the video, stay subscribed to the channel. See you again.